Hello, welcome to Unit 1, Lesson 15, Comparing Data Sets. Today's learning objective is to be able to compare and contrast situations using measures of center and measures of variability. All right, let's take a look at the first activity. So this activity says it gives you 4 different histograms along with their statistics that go along with them, and they represent 4 different people and their bowling scores from the last 25 games. What you need to do is choose 2 of these people to join your bowling team and explain why. So go ahead, pause the video, and work on that. All right, let's take a look closer at each bowler to see what we notice about them. So looking at person A, they have a mean of 118, a median of 111, standard deviation of 32.96, and an interquartile range of 44. Looking at their histogram, I can see that it is skewed right, where most of their data falls on the left, and there's points on the right as well, but not as many. So looking at this data, I recognize that although person A, they have a low mean score, but their larger variability tells us they have the potential to get a higher score. So although for the most part they tend to score on the lower end, there is that potential that they could score over 140. Okay, let's look at person B. Now person B has a mean of 131.08, a median of 129, a standard deviation of 8.64, and an interquartile range of 8. Looking at their histogram, it's very condensed, which means it tells us that there's not a lot of variability. So this person is definitely consistent in their scores. And their mean is pretty high, right? It's much higher than the mean for the previous bowler, so higher mean. The only thing is that there isn't that potential to get those higher scores above 160. All right, person C. So this person has a very similar mean to the previous person. They have a higher median of 145. Their standard deviation is pretty high, 45, and their interquartile range is really high at 74. So again, we see that this person has a high mean score, which could be beneficial to the team. But there's a lot of variety in their scores. So they potentially could score high or score really low. So scores are inconsistent. Potential to score both high and low. So that's something that you would need to take into consideration. This is probably somebody who needs a little coaching to kind of work on how maybe they release the ball, their form, things like that. Person D, so they have a median of 116, which is the lowest of all 3 players. A median of 103, which again is the lowest. Their standard deviation, though, is pretty high. It's the highest, and their interquartile range, although is not the highest, it is still pretty high. And we can see that the standard deviation from looking at the histogram is impacted because they have this outlier right here that doesn't really fall with the rest of the data. So they are consistent with the sense that for the most part, they're going to average on the lower end. So they're somewhat consistent, but there is that potential to get perfect games, right? A 300 is a perfect game in bowling. Potential to get a perfect game. But the thing you would want to take into consideration is that on a whole, they tend to score on the lower end. So you could make a case for any of these players. It really is just what you're looking for in a team member and what fits best with your team. All right, let's move on to activity 2. So for this activity, you're presented with 2 different dot plots that show the times of finishing a marathon for different age groups. So you have one that's an age group of 30 to 39, and then one that's an age group of 40 to 49. So what you're going to be doing is answering 2 questions, and while you're doing this, some things to keep in mind is that you want to try to look at the data informally instead of trying to calculate the exact measures of center and measures of variability. You can use estimates if you would like, if that helps you, but that's probably going to take you a little bit more time than if you just kind of look at the shape of the graph and how it sits on the dot plots. So I'm going to actually walk you through this one just because I don't want you to spend too much time on your calculator, and I want to focus more on that idea of looking at how the graph shifts. So with question 1, it says, which group tends to take longer to run the marathon? So if we look here at the 2 different dot plots, we can see that 30 to 39 is shifted farther to the right, meaning their times are less, and 40 to 49 is shifted a little bit to the right, and it's also more spread out. So I think we can come to the conclusion that based on where the center of the data falls, for the age group 40 to 49 is going to be slower. Now, I know in looking at that dot plot, there are some 40 to 49-year-olds that finish quicker than the 30 to 39-year-olds, but we have to look at the data as a whole group and not just at those individual people who ran faster than the 30 to 39 group. Question 2 says, which age group has more variable finish times? So again, I would recommend just looking at how spread out the data is, because to put this into your graphing calculator would probably take a little bit too long and not necessary. So for looking at these on times, we can see that the age group 40 to 49 is more spread out. So they are definitely going to have more variety of finish times. And you can even take a closer look at the middle half of the data, which would be represented by the IQR. So even like the middle part of the data, which would probably be about here, right? So the middle half is also going to be bigger than, let's say, this middle half of the data. So again, and actually that middle half is probably shifted more to the left, right? So that's another, not just how spread out the data is, but also if you were to calculate the IQR, or even just kind of looking at what the IQR could be on a box plot, we can see that the middle half of the data is more spread out for that age group. If you wanted to actually calculate the mean and standard deviations, I'll go ahead and give you those measurements. So or those calculations. So for the 30 to 39 group, so your mean is 294.5 minutes. The standard deviation is 41.84. The median is 65. Quartile 1 is 260. Quartile 3 is 325. And the IQR is 65. For the age group 40 through 49, those numbers, so the mean is 340.6. Standard deviation is 59.93. Median is 332. I just realized I made a mistake. Sorry, guys. The median for this group is actually not 65. It is 288.5. Sorry about that. Quartile 1 is 289. Quartile 3 is 381. IQR is 92. So just by looking at the data, we were able to make observations that you can make also with this data as well. So you can see the 40 to 49 group definitely has higher measures of center. So right, their measures of center 340.6 and 332 when compared to the other group are higher. They also had higher measures of variability, right? 59.93 and 92. And the 92 is even more significant because that's the middle data, and that's where like you're looking at like the numbers closest to the measure of center, to the middle of the data. So we can see that they are definitely more spread out. All right, so some things to keep in mind when it comes to choosing what's best, median or mean. I know we've talked about in the past before, if data is mostly symmetrical, then we would try to focus more on the mean. This data is not anywhere near symmetrical. It's very spread out, very kind of sporadic. So median is definitely going to be a better measure of center in this case. Also, since you're using the median, your measure of variability is going to be IQR. IQR, median go hand in hand. Mean and standard deviation go hand in hand. Also, we could, since I gave you the statistics that go along with these graphs, you could calculate if there are any outliers. We're not going to really worry about that today, but just remember you would figure out the IQR, multiply that by 1.5, and then subtract it from quartile 1, add it to quartile 3. Any numbers that fall outside of those two numbers are going to be considered outliers. In this case, I will tell you there are no outliers because there are no times, for example, in the age group 30 to 39, the number that you would be shooting for is 422.5, and there's no times greater than that. And then for the 40 to 49 group, it would be numbers greater than 534, which again, there's no one out who going above it. Looking at the graph, it looks like there might be outliers, but this is why it's important that we do that outlier work or the calculations to figure out what the outlier is. All right, let's move on to activity 3. All right, for this activity, you are presented with a bunch of different displays. And then on the next page, it gets into situations. So what you're going to need to do with this activity is determine the best measure of center and variability to be used based on the shape of the distribution. Then determine which set has the greater measure of center, which set has the greater measure of variability, and make sure that you're ready to why. So have a good explanation either written down or in your head. For time's sake, I want you to take 5 minutes. So pause the video just for 5 minutes. If you don't finish, that's okay. Try to get done as many as you can in those 5 minutes. All right, let's take a look at number 1. So number 1, both data displays are symmetric. So because they are both symmetric, we're going to want to use mean and standard deviation as our measure of center and variability. Now, looking at the two data displays, I want to know which one is going to have a bigger measure of center. So looking basically at the middle of the data, I see that distribution 1A has a -8, whereas B has a -10. So that tells me that 1A is going to have a greater mean because -8 is bigger than -10. Now for variability, I'm looking for how spread out the numbers are, and for 1B, I notice that most of my points fall in the middle, and then as I move outwards, there are fewer and fewer points, whereas it's the opposite for 1A. Most of my points start farther away from the mean, so I know that this one is going to have a greater standard deviation. Okay. For number 2, again, I'm still dealing with symmetric data. So again, I am going to use the mean and standard deviation for my measure of center and measure of variation or variability to figure out who has the higher first mean. Looking at both data, as I can see that my middle of my data falls between 19 and 21, whereas on 2B, it falls between 29 and 31. So 2B is going to have the greater mean. To figure out which one has a greater variability, I look at see how spread out the data is. 2A is significantly more spread out than 2B, so it's going to have a greater standard deviation. All right, 3A and B. So for this one, the data is not symmetrical. It's not even close to being symmetrical. So we are going to want to use median and IQR for this. Looking at the data to figure out my greater measure of center, I can see that for 3A, my centers fall somewhere in this area, whereas in 3B, it tends to fall somewhere in this area. So 3A is going to have the greater median. And then again, for variability, which one's spread out more, we can see that 3A is spread out significantly more than 3B, so it's also going to have the greater IQR. Let's look at number 4. So number 4, I'm going back to mean and standard deviation because again, the data is symmetric. To figure out my measure of center, which one has the bigger one, looking at 4A, my measure is going to be 100, whereas in 4B, it's going to be 90. So 4A definitely has the greater mean. For greater standard deviation, I look how spread out my data is. So the range is the same for both pieces of data, but in looking at the middle of each data piece, I can see that for A, there are more points closer to the middle, and as you get farther away, there are less points. 4B is uniform, so it stays consistent throughout, but regardless, it's going to then have a greater standard deviation because those number of points never change, whereas for A, the number of points get smaller as you move out from the middle. Okay, 5A and B. Now we are looking at box plots. For these, we're going to want to focus on the median and IQR because more than likely this data is not symmetrical based on the shapes of them. We don't know for certain if they are or not, so we're going to go with median IQR as our best guess. Focusing on the median for the distribution, we can see 5A is greater. It falls around 700. Whereas in 5B, it falls around 500, so A is going to have a greater median. For the IQR, we focus on the box part of the box plot, and we can see that this box is bigger than this box, so that tells us that it's also going to be a greater IQR as well. All right, go on to 6. So for 6 and 7, you're not given just data displays, you're just given situations. So 6A says a political podcast has mostly reviews that either love or hate. So if you think of a scale of 1 to 10, your points are either going to fall in either the 1 or the 10 section. And then 6B says a cooking podcast that reviews that neither hate nor love the podcast. So if we were to create dot plots, this will actually probably look a lot like our dot plot from question 1. For determining our measure of center and variabilities, the best one, it's kind of hard to tell because we're not given numbers. So it's kind of hard to say one way or the other. So just instead, it probably just makes more sense to focus on what was going to have a higher measure of variability and measure of center. So if we're thinking back to number 1, what our dot plots kind of looked like, the one where most of the points are on the outside are going to have a higher measure of variability. So greater. As far as a measure of center, even that we can't really calculate because we need numbers. So it really just depends on the data. So this one, the only thing we can really identify for sure is that 6A is going to be a greater variability. For 7, you've given 3 situations. So 7A, stress testing concrete from site A has 12 samples break at 450 pounds per square inch. Stress testing from concrete site B has samples break every 10 pounds per square inch starting at 450 and they last until the core is broken at 560. And then 7C says that they have 6 samples break at 430 psi and the other 6 break at 460 psi. So in all 3 situations, they all are symmetric. So therefore the mean and standard deviation is going to be the better measure of center and variability. In determining which one has the greatest mean, you're going to go with site B because the least value in that distribution is the same as the mean for site A, and it's also greater than the mean for site C. So that's its smallest data. So if its smallest data point is greater than the means of the other two data points, that also tells us that it's going to have the greater mean. The standard deviation will also be the greatest for B because we know A has a standard deviation of 0, right? It's always 450 pounds. And site C has all of its data within 15 PSIs of the mean. Site B, though, only has 4 values that are within 15 of it. So this one's going to be a greater mean and standard deviation. So I know that was a lot to take in. So a couple of things that you try to walk away from with this lesson is that when you're deciding between the mean and the median, really try to focus on the shape of the data display. If it's symmetric or somewhat symmetric, you're going to want to choose mean, whereas if it skews, you're going to want to choose median. When choosing variability, if you use mean for your measure of center, then you use standard deviation. If you use median for your measure of variability, you use IQR. Also, some other things to keep into consideration is that there are different ways to compare measure of variability for a data set. You can either exactly calculate the standard deviations or IQR or estimate them from a data display, or just look at the data display and see which one is more spread out. We talked about how with skew data you really want to use the median, and that is preferred because it more accurately represents the center of most of the data. Data that fall farther from the center impact the median less than the mean, so the median remains near the typical values. Whereas the mean is preferred for symmetric or somewhat symmetric because it takes into account all of the values in the data when being calculated. So that's it for today's lesson. Go ahead and don't forget to submit these notes and get started on your cool down. Thanks for watching.